So this is the physical science lesson video for section 4.2, and as always, if you'll subscribe to my channel, you can have all my videos for the whole year in one spot. So we briefly discussed the history of the atom in the section 4.1 lesson video, so now let's talk a little bit more about that structure. So protons, electrons, and neutrons are the subatomic particles that make up an atom. A proton is a positively charged subatomic particle that is found in the nucleus of an atom, and it has a positive 1 charge. Okay, so protons are in the nucleus, they have a positive 1 charge, each one does. And I don't know what else I was about to say about protons because that's all there really is to know. So an electron, on the other hand, is a negatively charged subatomic particle that is found in the space outside the nucleus, which we call the electron cloud. An electron has a negative 1 charge. And then a neutron is the neutral subatomic particle that is also found in the nucleus of an atom. It has the same mass as a proton. So protons and neutrons are in the nucleus. So the nucleus is made of positive and neutral particles, which means the nucleus overall is positive. And then the negative electrons are in the electron cloud around the nucleus. Protons, electrons, and neutrons can be distinguished by mass, charge, and location. So a proton has a positive 1 charge. Its relative mass, which means if we pretend a proton has a mass of 1, it doesn't, but if we pretend, then it has a relative mass of 1 and it's located in the nucleus. Neutrons have a neutral or no charge, so I put 0. If a proton's relative mass is 1, a neutron is pretty much also 1. So what we're saying is protons and neutrons have about the same mass. It is also located in the nucleus. An electron, on the other hand, has a charge of negative 1. And its relative mass is 1 over 1,840. So in other words, it's 1,840 times less mass than a proton or a neutron. Okay, so like you can just pretend like that's 1 over 2,000. It has 1/2000th the mass of a proton or neutron. So what that means is electrons are much, much smaller and have a lot less mass, and they're located in the electron cloud. So since electrons are so much smaller, when we talk about the mass of an atom, we only focus on the protons and neutrons because the electrons are so small. It would be as if I weighed myself on a scale and then I pick up a paperclip and re-weigh myself. The paperclip's so small in comparison to my body weight that it's not going to change the number on the scale. And that's what an electron is like based on a proton or a neutron. So the atoms of any given element always have the same number of protons. So if an element is boron, boron is number 5, so every boron atom will have 5 protons no matter what. The atomic number of an element equals the number of protons of that atom of that element. And on the periodic table, your atomic number is at the top. So helium has atomic number of 2, that means every helium atom will have 2 protons. Atoms of different elements have different numbers of protons. So if I found an element that only has 1 proton, I know for sure it's not helium because helium has to have 2. I could look on the periodic table and see that element number 1 is hydrogen, and then I would know that element is hydrogen. So in other words, elements are identified by their protons. We'll talk about how neutrons and electrons can be different, even in atoms of the same element. So each positive charge on an atom is balanced by a negative charge because atoms are neutral. So that means if I have 3 positive protons, I have to have 3 negative electrons to cancel it out. So the atomic number of an element also equals the number of electrons in an atom. But remember, I told you electrons can change. We'll talk about that when we get to ions. But for right now, if I have 3 protons, to cancel that out, I have to have 3 electrons. So if you know the atomic number of an atom, then you know how many electrons it has as well as protons. The mass number of an atom is the sum of the protons and neutrons. So if you remember from my weighing example with the paperclip, electrons are just so small that they don't make that much difference in the mass. So we only focus on protons and neutrons in the nucleus of the atom. So our number of protons is our mass number, our number of neutrons is our mass number minus atomic number. Because mass number is protons and neutrons, atomic number is just protons. So if I subtract, I'll get neutrons. So for example, if I know my mass is 4 and my atomic number is 2, 4 minus 2 gives me 2 neutrons. So for this, I would know atomic number is 2, so that means 2 protons. Since I have 2 protons, I have to have 2 electrons to cancel it out. And then 4 minus 2 gives me 2 neutrons. Now those numbers aren't always the same, so don't think like, oh, well, obviously they're just all 2. It doesn't always work that way. So isotopes, what are isotopes? Isotopes are atoms of the same element that have different numbers of neutrons and different mass numbers. So isotopes, because they're the same element, they have to have the same number of protons. So if we're talking about helium, like on the previous slide, it still has to have 2 protons, but it has different numbers of neutrons. And because the neutrons are different, the mass numbers are going to be different. Isotopes of an element have the same atomic number, but different mass numbers because they have different numbers of neutrons. So for example, here we have helium-3, because of course you see 3 particles. 2 of them are protons because it is helium, and 1 of them is a neutron. Well, here we have helium-4 because you can see you have 4 particles now, but we still have 2 protons to identify that it is helium, but now we have 2 neutrons. So they have different mass numbers, but they're both helium because they have the same amount of protons. Isotopes are referred to in the following way. You can say carbon-12, carbon-13, carbon-14. So you give a dash and then you tell the mass number, that way you know. So for example, carbon has an atomic number of 6. So that means all carbon atoms have 6 protons. Well, this one has 6 neutrons, because 12 minus 6 is 6. This one has 7 neutrons, because 13 minus 6 is 7. This one has 8 neutrons, because 14 minus 6 is 8. So you can see they all have 6 protons, but that number of neutrons changes. With most elements, it's hard to notice any differences in the physical or chemical properties of their isotopes. So in most substances, the isotopes act the same, because the main thing that you'll find as we get more into the chemistry portion of physical science is that the chemical reactivity and properties are based on the electron arrangement. And so right now we're just talking about neutrons in the nucleus, so they don't make that much of a difference most of the time. So, name the 3 subatomic particles. Well, proton, neutron, and electron. Hopefully you knew that before you got to this class. Number 2, name 3 properties you could use to distinguish a proton from an electron. Well, you could use the charge. A proton's positive and an electron's negative. You could use the mass. Relative mass of protons 1, relative mass of electrons 1 over 1840. Or you could use location. Location of protons in the nucleus and electron is electron cloud. So you could use the charge, the mass, or the location. Number 3, which characteristics of an atom always varies among atoms of different elements? Remember, if atoms are different elements, then they have to have a different number of protons. Everything with 5 protons, no matter what's going on with electrons and neutrons, is going to be the same element, which is boron. So if they're different elements, they have to have different numbers of protons. Remember, protons identify an element. Number 4, how are the isotopes of an element different from one another? Well, they have different numbers of neutrons, which means they also have different mass numbers. So there's 2 for this one. They have different numbers of neutrons, which means they also have different mass numbers. And then number 5, what do neutrons and protons have in common? Well, they're both in the nucleus. And how are they different? Well, protons have a positive 1 charge, neutrons have no charge. Okay, so they're common and they're both in the nucleus. They're different because protons have a positive 1 charge and neutrons have no charge. How can atoms be neutral if they contain charged particles? Well, remember, to become neutral, if we have 5 positives, we got to have 5 negatives. So we can say the number of protons and electrons is the same, so the charges cancel. Okay, so the number of protons and electrons is the same, so the charges cancel. And then number 7, what's the difference between atoms of oxygen-16 and oxygen-17? Well, for oxygen, it's number 8 on the periodic table, so they both have to have 8 protons. So what would be different? It would be number of neutrons. So 16 minus 8 is 8, so oxygen-16 has 8 neutrons. 17 minus 8 is 9, and so oxygen-17 has 9 neutrons. So you can say oxygen-16 has 8 neutrons, whereas oxygen-17 has 9 neutrons. All right, number 8. What property do protons, that probably should say and electrons have that neutrons do not? Surprise, surprise, there's a typo. Where's my mark? Okay, this should say and. All right, so what property do protons and electrons have that neutrons do not? Well, protons and electrons are both charged particles. Neutrons are neutral. Okay, so protons and electrons have a charge and neutrons do not. And then number 9, which is our last one, explain why it isn't possible for an atom to have a mass number of 10 and an atomic number of 12. Well, mass number is the protons and the neutrons. Atomic number is just protons. So you can't have more protons than you have of protons and neutrons. At most, atomic number and mass number can be equal, but your atomic number can never be greater than your mass number. Okay, so you can just say atomic number is number of protons, so mass number is protons and neutrons, so it cannot be less than the atomic number. Alright, so hopefully now you understand a little bit more about isotopes and the difference in protons, neutrons, and electrons.